Unit 5, Differentiation. Section 1, Limits of a function. Section Objectives. By the end of this session, the student will be able to 1. Use a table of values to estimate limits of a function. 2. Evaluate limits algebraically. Limits of a function. Let us look at how the function f of x equals x squared minus x plus 2 behave. If x approaches 2 from two different points, that is from the right hand side and then from the left hand side. In the table below, x approaches 2 from the left hand side, which is from 1 to 1.999. In fact, it can be 1.99999. It can be as close as possible. And from the right hand side, x approaches 2 from 2.5 up to 2.001. And again, in fact, this 2.001 can be 2.00001. It can be as close as possible to 2. And we observe that the function f of x behaves in a way. As x is approaching 2 from both sides, the function f of x tends to be close to 4. That is when x approaches 2 from the left, that is 1.999. The function f of x gives 3.997001. And when it approaches 2 from the right, that is 2.001, the function gives 4.003001. Then we can see that the function is as close as 4. Let's see what happens in the next slide. From the previous slide, and that is from the table, we have observed that as x approaches 2 from both directions, that is from the left hand side and then from the right hand side, the given function f of x is as close as 4. And we express this by writing that the limit of the function f of x, which equals x squared minus x plus 2, as x approaches 2 is equal to 4. The notation for this is written as lim x is approaching 2. X squared minus x plus 2 is equal to 4. Let us look at some definitions. In general, we have the limit as x is approaching a of the function f of x to be L. And L is the limiting value of the given function as x is approaching a. Alternatively, this can be stated as the function f of x approaches the limiting value L as x is approaching a. Let us find the limit of the given function, the limit as x is approaching 1, the function x minus 1 over x squared minus 1 using tables. Now, using tables to find the limit of the function, x must approach 1 from both sides, from the left hand side and then from the right hand side. So in the table, x approaches 1 from the left hand side, that is from 0.5, 0.9 up to 0.999. And when it approaches 1 from the left hand side, the given function f of x behaves as x is approaching 1, the function f of x is approaching 0.5. Also, when x is approaching 1 from the right hand side, that is from 1.5, 1.1 to 1.999, 0, 0, 0, 1, the function f of x gives 0.5000, which is 0.5. So therefore, we can conclude that the limiting value or the limit of the function x minus 1 over x squared minus 1 as x is approaching 1 is equal to 0.5. In our previous slides, we have learned how to find limits using tables. Now we want to find limits algebraically. To find limits algebraically, we substitute the value which x approaches into the given function. For instance, if the given function is x squared minus x plus 2, and since this is a polynomial, then our limit is 2 squared minus 2 plus 2, which gives 4. Also, to find the limit of the function x minus 1 all over x squared minus 1 as x is approaching 1, we realize that when we substitute 1 into the function, the denominator gives 0. And since the denominator gives 0, it makes the function undefined, which means to find the limit, we need to simplify before the substitution. Now simplifying, the limit x is approaching 1, x minus 1 all over x squared minus 1 gives x minus 1 all over x minus 1 into braces, another braces x plus 1. That is, the denominator is the difference of 2 squares. Now, x minus 1 in the numerator cancels x minus 1 in the denominator, which gives the limit x is approaching 1, the 1 over x plus 1. This gives 1 over 2 when x is substituted into the function. Example 2. We want to find the limit of the function, the limit as x is approaching 3, the function f of x algebraically. If f of x is equal to x squared minus 3x all over x minus 3. Now, looking at the denominator, when x is equal to 3 is substituted into the given function f of x, the denominator gives 0. And since the denominator gives 0, it implies we need to simplify before the substitution. And hence, the numerator x squared minus 3x has a common factor, which is x. So x is factored out. Then we have the limit as x is approaching 3, x out into braces x minus 3 all over x minus 3. Now the x minus 3 in the numerator cancels x minus 3 in the denominator, which gives the limit x is approaching 3, then the function now is x. Now when we substituted x is equal to 3 into the function x, that gives 3. Example 3. We want to determine algebraically the limit of the function f of x equals 2x squared minus x minus 6 all over x minus 2 as x approaches 2. Now when we do the substitution, that is x is equal to 2 into the given function, we realize that the denominator gives 0. That is 2 minus 2 equals 0. And since the denominator is equal to 0, it makes the function undefined. And hence, we need to simplify the function before the substitution. But looking at the numerator of the given function, 2x squared minus x minus 6 is a quadratic expression. So simplifying that, we multiply the coefficient of x squared by the constant negative 6, which gives negative 12. And we find 2 factors of negative 12. If we multiply, we have negative 12. but if we add, we have -1. And these factors are -4 and +3. So when we simplify, this gives the limit as x is approaching 2, x minus 2 into braces, another braces 2x plus 3 all over x minus 2. Now the x minus 2 in the numerator cancels x minus 2 in the denominator, giving the limit x is approaching 2, then into braces 2x plus 3. Now this 2x plus 3 is a polynomial function, so we can now do the substitution by putting x is equal to 2 in place of x, which gives 2 times 2, 4 plus 3, and it gives 7.